This is the ulna of a velociraptor, so it's one of the lower limb bones, or the forelimb. And I found these bumps, these quill knobs along the back of the ulna, which is where the ligament that attaches the feather embeds itself in the bone. They're actually quite small, so I felt them actually before I saw them.
And these quill knobs can be found on modern birds.
What's interesting about Velociraptor is it's one of the larger of the dromaeosaurs known that we actually have direct fossil evidence for its feathers. We have good reason to have predicted that these animals would have been feathered because we know their earlier, smaller relatives had feathers.
Beyond cosmetics, these feathers are a further confirmation of the close connection between raptors and birds.
They're not just dinosaurs, but they're actually a particular kind of dinosaur. They're embedded in the tree of life within the group of predatory dinosaurs. They're in fact more closely related to things like Velociraptor than Velociraptor is related to something like Tyrannosaurus.
Though feathers are perhaps the most dramatic connection between raptors and birds, there are many similarities that are not just skin deep.
When you look at a bird today, a lot of what you see is in fact dinosaur and not as much bird as you think. The hollow bones are in fact a theropod feature. Those are around for 210 million years. The wishbone that you see within a bird, that's also a theropod feature, evolved long before flight ever evolved.
All those guys have, for example, a specialized wrist bone called a semilunic carpal. It does a big sort of flex motion like this, which in a predatory dinosaur is useful for grabbing prey. It is exactly the same motion that a bird does in their downstroke of a flight. And that's one of many anatomical characters that show us that birds are dinosaurs.
But why did these features lead to flight in